Okay, here is my award-winning drawing of what's going on with this particular situation. So it says a squirrel is in a tree holding a chestnut at a height of 46 feet above the ground. It drops the chestnut, which lands on top of a bush that's 36 feet below the squirrel. The function h of t, which really is height as a function of time, is negative 16t squared plus 46, and that gives the height in feet of the chestnut as it falls, where t represents time. When will the chestnut reach the top of the bush? Okay, so here's the situation again. The chestnut and the squirrel are 46 feet above the ground, but the chestnut is only going to drop 36 feet because it's going to hit the top of the bush, and the bush is 10 feet tall. So a little thinking, hopefully, will tell you that we want to know the time when the height is 10, okay? Okay, so what I'm really going to do is I'm going to take this equation. I'm interested in how much time goes by when the chestnut is still 10 feet above the ground when it hits the bush. So I'm going to put 10 in here and make this an equation and put negative 16t squared plus 46 in on the other side and figure out what the time is in that case. All right, so I'm going to go back over here. Let's see. Clear this out. Okay, I've gone ahead and just hopped over here to Desmos because my y equals 10 is a nice red line. My y is equal to negative 16x squared plus 46 is this blue parabola. And hopefully a little intuition will tell you that, yeah, obviously the highest point or the maximum of the parabola is at 46 feet because that's where the little squirrel is dropping the chestnut from. Now, oops, if I zoom out a little bit, we can see that honestly, he's up here and the chestnut is just falling. It's not like the chestnut is doing anything and going up and coming down. So really this part, this half of the parabola, I don't really need. But I do need to hone in on what is this intersection right there. So we're going to come up here. And if I click on that, that's 1.5 comma 10, which means that that chestnut is going to fall for a second and a half before it gets to the 10-foot mark. You have another zero or another solution back here at negative 1.5, but since this is a situation involving time, the negative side doesn't make sense, okay? So really, because this is only a drop situation, really only need to look at half the parabola. So 1.5 is our time. Okay, so at 1.5 seconds, the height is still 10 feet. All right, now I'm on page 829 and I'm looking at example 4a. And it says a dolphin jumps out of the water. The quadratic function h of t is equal to negative 16t squared plus 20t models the dolphin's height above the water in feet after t seconds. How long is the dolphin out of the water? And use the level of the water as a height of 0 feet. So when the dolphin leaves and then when it re-enters again, its height is 0. So basically the dolphin's going to come up out of the water and then arch and come back in. So first of all, I'm just going to go ahead and split and make two functions. I'm going to say this is one of my functions, 0, and this is my other function. And the reason why I'm going to do that is just simply because on the TI-83, it seems to be a little easier to use the calculate the intersection option rather than using trace to sort of figure out where the two lines are intersecting. Okay, so I'm going to go over here, clear that, clear all this, And I'm going to put in y is equal to 0 for one of my lines. And by the way, when this is graphed, it's going to run right along the x-axis, so you're not going to actually be able to see that line, but it still will be there. And then negative 16x squared plus 20x. Clear all this. My x minimum, I'm going to say is just -1, so it's not just like right at the end. I don't think this is going to take long, but I'll put 3 in just for the sake of argument. I'll put in like -1 for my y minimum, just so that the y-axis is a little bit higher. And then I don't know how high this dolphin's going to get. I'll put in 20. Let's see what we get. Okay, so there's the dolphin jumping up out of the water, reaching a maximum, and re-entering the water. Okay, this first 0 is literally at 0, 0. Okay, then he goes up, 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 and I need to know right there when he splashes down, because from here over to here is his whole entire trip out of the water. So I'm going to go ask it to calculate the intersection. And that is at 1.25 seconds. So he goes out of the water at 0 seconds, arches up, comes back into the water at 1.25 seconds because his height's 0 again.